Hi. So, look, all the things that we've learned about logarithms and their derivatives will allow us to find a very simple ways of calculating growth rates of different functions. And look, let's start with something like this. Let's just say that y is equal to u times v. And u is some function of time, and v is some function of time. Look, how can I calculate growth rates? Well, let's use the most common way to do things in this class. First logarithmize, then differentiate. So I'm going to take this expression and I'm going to logarithmize it. And as a result, I will obtain this. And now look, u and v are functions of time. So consequently, y is also a function of time. I can differentiate this entire expression with respect to time. What am I obtaining here? Look, here y is a function of time. So I'm obtaining y prime over y. Here, u is a function of time. I'm obtaining u prime over u. And here, I am obtaining v prime over v. So what do I have here? This is growth rate of y, which is equal to growth rate of u plus growth rate of v. And look, this simple manipulation allows us actually to take some very powerful conclusion that growth rate of a product is equal to the sum of growth rates. Okay, how can we apply this? Well, there's a lot of examples where we can apply it, but let's start with something very common. Let's just say that Yn is nominal GDP. So nominal GDP is, in other words, real GDP multiplied by price level. Look, we could go through steps, but let's just use the formula to obtain the relationship between nominal GDP, real GDP, and the growth rate of nominal, real GDP, and price level. So we get that growth rate of Yn, nominal GDP, should be equal to growth rate of real GDP plus growth rate of price level. How do we call the growth rate of price level? Of course, we call it inflation. So you see from that growth rate of nominal GDP is equal to sum of the growth rate of real GDP and the growth rate of price level. Okay, now this rule that you see over here can be very easily extended to different cases. For example, if I have y equals u over v, but I maintain all other assumptions. So u is some function of time, v is some function of time. I can use the same steps to get, let's already write it as growth rate of y is equal to growth rate of u minus growth rate of v. Well, there's not much more philosophy to it. It's basically all the same step. Excellent. And again, let's illustrate this one with a practical example. Let's just say that, well, not let's just say, this is how it is. GDP per capita is equal to GDP over number of humans. I don't want to use F. Population. Out of this, and knowing this formula, we can right away say that the growth rate of GDP per capita is equal to growth rate of GDP minus growth rate of population. Okay, now let's tackle one more case. This one is a little bit more unpleasant. Okay, so now let's just say that y is u plus v and everything else stays. Well, again, we will start by logarithmizing. Unfortunately, there's nothing more we can do. Remember, it's a plus. We cannot do nothing with it. But I can still differentiate both sides with respect to time. And look, here, what I'm going to get is again y prime over y, right? And over here, look, this is logarithm of some function. So we will have original function in denominator and derivative of this function in numerator. And derivative of a sum is sum of derivatives. We are obtaining this. Now, this expression does not look like we could use it much, but let me just do one simple thing. I can divide it into two separate expressions, like u prime, u plus v, plus v prime over u plus v. Right? Now, let's remember the definitions that we had of growth rate. And I could say the growth rate of v is equal to v prime over v, right? But this implies that if I multiply both sides by v, that v prime is equal to growth rate of v times v. By the same token, if growth rate of u is given by u prime over u, this implies that u prime is equal to growth rate of u times u. Okay, now let's use it and let's substitute in the formula. Look, we can replace this one with growth rate of y right away. And look, u prime could be replaced by ru times u, or simply u over u plus v times growth rate of u. And by the same token, here we will have v over u plus v growth rate of v. And look, this expression is actually telling us quite a lot. Why? Look, let's notice a very simple thing. If I'm going to take this coefficient on growth rate of u, and I'm going to add to it this coefficient on growth rate of v, I'm going to get 1. So look, it turns out that the growth rate of a sum of two expressions is equal to the weighted average of the growth rates. Look, how does it work? It makes perfect sense when you think about it. Look, let's just say that we have a situation like this. Let's just say that y is equal to u plus v, and at some moment u is equal to 100 and v is equal to 10. Now, if, let's just say, if they are both growing by 10%, right? What will be impact of This is going to be easier. Yeah. They both grow by 10%. By 10%. Impact of which variable on y will be stronger? Well, of course, u, because look, share of u in total is 90%, while v just 10%. And now, 10% out of 90 is additional 9 units. 10% out of 10 is additional 1 unit. But of course, look, in this case it didn't really matter because they had the same growth rate. Now, let's imagine a different situation. Let's just say the growth rate of u is, let's just say, still 10%, but growth rate of v is 30%. Okay, so by how many percent is going to, y is going to increase? Well, if we want to find that growth rate of y, you would use 9 over 10, right? Times 10% plus 1 over 10 times 30%. And if we add it all up, we will be able to find what is the growth rate of y. And you see that actually the bigger is the initial value of one of these components, the bigger its impact on the value of y. Okay, now let's use again very simple example to explain how it works. Look, imagine that we've got closed economy. And in this closed economy, GDP is equal to consumption, investment, and government spending. So, in other words, we can write the growth rate of GDP is equal to consumption share of GDP times growth rate of consumption plus investment share in GDP times growth rate of investment plus government spending share of GDP times growth rate of government spending. Okay. Thank you very much for your attention. In the next video, we're going to cover